questions. Good morning. So last lesson we did a linear search in 1 dimensions. And remember we said a linear search means you start looking for something. Where do you start? You start at the beginning. And then you keep going in an ordered way. You start at the first place, the second place, the third place. And each time you go and look at a new place, you say, have I found what I'm looking for? And if you have found what you're looking for, you stop. But if you manage to get to the end of all of the places you can look and you haven't found it, then you also stop. So that's a linear search. You just go through from the beginning to the end. Today's lesson, we build on that, but we're now looking in 2 dimensions. Remember, a 2D shape is like a rectangle. It can go in the x-axis and the y-axis. So a 2-dimensional data structure means you can't just start at the beginning and stop at the end, because where is that? You can go in 2 directions. Same principle, but a little bit more complex. A 2-dimensional data structure can be used to store records. And by records, I might mean like all the students here in my register. You would have a name, first name, a last name, a date of birth, a target grade, a how well you're doing, number of positives, number of negatives. All of that data might make a record. And then I'd have a list of records. So I've got a 2-dimensional data structure, a list of lists. Each list is one person, and then a list of lists to have lots of people. So we can do a linear search with that. This is a 2-dimensional data structure. For now, let's just look at this first line, the inner square brackets. That is a 1-dimensional list from 1 to 1 to 0.98. That's a 1-dimensional list. It's a record. How do I know it's a record? Well, it's just a list and it contains different data types. We've got an integer, we've got 2 strings, and we've got a float. But once we have more than one record, as in a list of lists, that's now 2-dimensional because we need to know which row we're on and which column we're on. Those are the 2 dimensions. So how do we search? Well, here is the flowchart. We start and we stop. We set index, that's where we're looking, to 0 to start at the beginning. We ask what we want to look for, like, I want to find Alice Abel, please. And then we say, is the item at the position we're looking for equal to what I'm supposed to be looking for? Yes, great, done. No, look somewhere else. Have we got to the end? No, keep looking. That was our 1-dimensional one. But actually, it's a little bit different because this time we've just got an extra indexing expression. It's almost identical, look. This is 1-dimensional. This is 2-dimensional, 1-dimensional, 2-dimensional. The only difference is we've got an extra indexing expression. What on earth does that mean? Remember, index means like the page number of a book. So think of a 1-dimensional data structure like a book with a page, and each page only has 1 letter on it. Now, if you think about a 2-dimensional data structure like a book where you have a sentence on each page. So you know the page number, and then you can find out how far through the page you are. We've got 2 indexing expressions, the page number and how far through the page we are. So I think it's more helpful to have a look at some data here. A worked example, yeah, that's not going to make sense until you actually see it. So let's have a look at the code here. Here's a 2-dimensional data structure showing films. What do we actually have to do? Here's a flowchart for how to search for it. That's just what we had in the PowerPoint. And we have a dry run. That just means running the algorithm in your head. What's the length of the list? Well, it's a 2-dimensional data structure. The length of a 2-dimensional structure is just how many you've got. So 1, 2, 3, you can carry on counting, etc., etc., etc. So open up CT23 for me, make a start, and when we get to the code, we'll go through it together. So just a reminder that it might help you to split your Word document. If you go View and Split, then you should be able to still see the table and part of your algorithm at the same time, which might really help. So let's have a look. What's the first value of index? Well, it's just going to be 0. What's the final value of index? Well, you'll have to go through the whole algorithm here and see. Each time you increment it and you stop when index is equal to the length of the list. So that should help you with that question. So we'll do a worked example. For 1995, what is the final value of index? Well, let's see. We start, and index is set to 0 to begin with. We enter the target date, and our target date is 1995. That's what the table tells us. Then, list index 0. What does that mean? Well, index is 0, and we're looking at the first item in the table on the first row. So that means we are looking at this value, because index 0 tells us we're looking at the first row. Index 0 and then there's another square bracket 0 tells us we're looking at this item, 1994. So is that equal to the target? No. Increment index. So index is 1. It was 0. It's now 1. Is index the length of list? Well, what was the length of the list again? I can't remember. I don't think it is it, but it was 1, 2, 3, 4, 5, 6, 7, 8. Sorry, that's me when I did the keyboard shortcut to unpause it. So index is 1. 1 is not equal to 8. No. Have we found it at the next place? Let's split so we can see what's going on here. No, I haven't. So we'll increment the index to make it 2. Is 2 the end? No, it's not. Now 0, 1, 2. Oh, we've now found it. Pulp Fiction in 1994. Oh, no, we haven't. We want 1995. Sorry. Which means we need to increment it to 0, 1, 2, 3. No, haven't found it there. 4, 5, 6, 7. Oh, at last we have found it. So if we found it, then we return list index. So that means we return all of this and we stop. And when we stop, we have the index of 0, 1, 2, 3, 4, 5, 6, 7. There we go. So what's the final value of index? It's going to be 7. What will it be for 2010? Well, it'll be 0, 1, 2, 3, 4, 5, because we find it at position 5. The return value itself is going to be all of this data, probably separated by, can we paste that in there? No, that's really irritating. You have to write it like this. What does the return value mean? It means we found a film released at that year. So I'll give you a couple more minutes and then we'll go through the next question. The next question is hard, so we'll go through it together and see how we get on. All right, so question 2 is a rearrange code one. These come up in the on-screen exams and you love them or you hate them. They are both good and bad. They're good because you don't have to write any code at all, but they are confusing because these are all jumbled up and you've got to kind of get yourself into the mindset of the person who wrote it. So, oh, don't tell me that this is a picture. That's a right pain in the backside. Let's find where we can download it from. So here we go. I'm on the VLE now, half term 4, CT23 we're on. Where's it gone? There it is. And it's activity 2. Let's open it up in Thonny. And there are some really useful keyboard shortcuts to help you in your on-screen exam. Here we go, here's the code. Let's put the question paper over here. And it just says we need to rearrange it basically. Here's the Python code that implements a subprogram that searches through the data structure by surname. So all of this is fine. Don't jumble that up, that's fine. It tells you where it's begun to be jumbled and where it's stopped being jumbled. And we have to sort all of that out. We don't have to do anything with this. This is all fine. Don't change that. So, useful things. First of all, use your keyboard rather than your mouse. There's a home button and an end button. The home takes you to the beginning, the end takes you to the end. If you hold down Shift and press home and end, it will select the whole line, which is really useful. All of you know how to Control C and Control V, but don't do that, please, because you end up with a copy of each line. Instead, Control X to cut and Control V to paste means you can move things into a sensible order. So yeah, I think there's a mistake in this code. Look, on line 29, there's a line of code as part of the comment. Well spotted. I won't name you because we're recording, but you'll get a class charts positive. So yeah, there should be an extra line of code on here. we need to work out what's going to happen. So I'm going to scroll back up to the flowchart. Again, in your on-screen exam, sometimes you're given a flowchart and you've got to implement it. So let's have a look. First of all, set index to 0. That looks quite sensible, but we're inside a subprogram, so I'm going to indent it so it becomes part of the subprogram. Get the target date. Well, we've already got the target date as a parameter. Then we can say list index 0 is equal to target. Well, that looks like what we want to try and find, but this looks like a while loop to me, something that keeps on going round and round. So I will get this, Control X, and put it up here. But even before we do that, I think we'll have a while not found and more items, because that's going to repeat lots of times. If that's a while loop, the thing underneath it needs to be indented. What does the while loop do? Well, we don't care at the moment. We just know it needs a found and more items. So we need to know what found is. Home, Shift End, Control X, pop that above here. We need to know what more items is. Control X, pop that in here. Okay, so we're all right so far. If P list index 1, what on earth does that mean? Well, let's have a look. Where is the table? So P list is the parameter that we're provided with, the data that comes into our find by surname, and it's a two-dimensional data structure. So P list is a two-dimensional data structure. Index means which row we're looking at, and 1 means which column we're looking at. And we're looking to find by surname, so we're interested in this column. So if that is equal to, as in if the column we're interested in is P target, that's the parameter we're provided with, the surname we want to find. So at that point, we can have a look at this. If it isn't what we want, then we want to increment our index. That sounds to me like this. Index equals index plus 1. And then we've got an if statement to say, are we at the end of the list? If index is equal to the length of the P list. And then it looks like we go back round in our while loop. So that'll be the while loop here. But there's some more stuff going on here. Because if we do find what we want, that sounds like an else to me. I made a logic error, which I've just spotted. You might have spotted it as well. I'm sure I've made lots of others. Notice the else must be lined up with the if. Indentation's important in Python. So this is saying now, return list index. Return student. Well, we've got some more stuff here. Oh, here we go. Student P list. That means we've found what we want. Good. And then outside of the loop, oh, in fact, this is my logic error. Found equals false. We assume we haven't found it yet, but when we do find it in here, I think we should pop that in there. So I made another logic error in here as well. We assume that there are more items to look for, but if we get to the end of the list, then there are no more ones to try and find. So if we are at the end of the list, then there's no more to look for. That makes more sense, doesn't it? Well spotted. Okay, we're almost there. We want to return the student. We want to do that at the end of the while loop, so in line with the while loop. So we don't return every time the while loop repeats, which would be that. We want to return after the while loop is finished. And then we've got this lurking at the end. I think this should go at the start, so that if we don't find the student, then we can return an empty list at the end. I think that's going to work. Let's test it and see, and then let's remind ourselves why we like Thonny so much. Let's see, we'll run it. Come on. Good, so we found Cooper, but we haven't found Murray. Just a reminder of the useful stuff in Thonny to help. If you set a breakpoint over here, double click, and go run and debug nicer, It will pause when it gets to that blob, double click blob. And when it pauses, you've got some choices. You can step over, step into, or step out. Step over will run a line at a time. Step into will run part of a line at a time. So let's see. F6, index set to 0, student set to an empty list, found is set to false. You can see all the variables here. At this point, I don't want to run a whole line. I want to run part of a line. So I'll press F7. While not found, well, what is found, first of all? Found is false. So what's not false? True. Okay, and more items. What's more items? More items is true. Then I'm saying whilst true and true. Have I got both of these to be true? Well, yes, I have. So that's just true. Thank you, Thonny. That's really helpful. I'm aware I'm talking to myself. I am going slowly insane. If plist index brackets 1, well, what on earth does that mean? Well, first of all, what is plist? Plist is a list of that. It's a two-dimensional data structure. I'm just pressing F7 all of the time. Oh my goodness, I need to scroll across to see what's happening here. So I found the one I'm interested in. That was plist square brackets index. Then I want to find the item at index 1, which is going to be able. There it is. And if that is not equal to our target, well, what's the target? The target is Cooper, because that's the parameter we were passed in. Is able equal to Cooper? That evaluates to true, because, sorry, it said if it was not equal to Cooper. And you can step through. So I would recommend setting that breakpoint, stepping through with F7 until you understand exactly what happens. Really helpful, powerful debugging skills. So for activity 3, we've got to test an algorithm with different input. So you get given, well, that's nice, isn't it? You've got this, which is pretty much the answer to activity 2 here, if you were struggling with that. That's nice. Let's run it and see. We need to put an input of 126 in, and it works. We found somebody with an ID of 126. So I don't think there is any validation required here. And it should work as well also with 199. Oh, it's so slow whilst I'm recording. There we go, 199. And it's not found, so no correction or validation needed. But if we try it with something that is empty, it's going to crash. Why is it going to crash? Because on line 38, it's trying to convert the return value from input, which is a string, into an integer. And if we don't type in anything, that string, an empty string, cannot be converted to an integer. It's going to fail. So we want to do a presence check here. That's what it's asking us to do. So think of the different types of validation. You might want to check your notes about presence check, length checks, lookup checks, all of those. And then activity 4, presumably you've got to actually implement them. So no extension activity beyond activity 3 and activity 4. Just want to remind you that we do have the 3 practice exam questions on compete.with code.uk. That's what you should be doing for your extension activity if you get to that point.